You open a can of tuna without thinking twice. You walk into a supermarket and pick salmon off a shelf, sealed in plastic, flown across an ocean, chilled to exactly the right temperature. Getting fish today takes seconds. But for 99% of human history, there were no supermarkets. No boats with sonar. No fishing line from a factory. No hooks made of steel. For over 160,000 years, every single one of your ancestors had to look at open water, a river, a coastline, a tidal pool, and figure out how to pull food out of it with their bare hands and whatever they could find. So how did they do it? And why does the answer completely change what we think we know about early human intelligence? Look at the human hand. Soft palms. Flat nails. No claws, no webbing between the fingers. Bears have curved, hooked claws designed to snatch fish mid-leap. Osprey have reversible outer toes that lock onto slippery bodies. Herons stand motionless for hours, then strike in under 100 milliseconds. Evolution tuned their reaction time for exactly one purpose. Every single predator that eats fish has a body specifically built for it. We don't. And yet, across every continent, in every era of human prehistory, archaeologists find the same evidence people were eating fish. Shellfish, river trout, ocean tuna. In some sites, fish bones outnumber animal bones 3-1. When you see a pattern like that across all of human history, you stop thinking it was an accident. You start asking what our ancestors actually invented to make it happen. In 1997, paleoanthropologist Hilary Deakin and his team at Stellenbosch University published findings from Blombos Cave in South Africa, a site that would rewrite the timeline of human behavior. They found perforated shells, ochre tools, and fish bones dating back 75,000 to 100,000 years. Not opportunistic scavenging. Deliberate, repeated exploitation of marine resources. This pushed coastal fishing behavior far earlier than mainstream science had assumed. Then there's the work of Dr. Francesco De Rico, a cognitive archaeologist at the University of Bordeaux, who analyzed bone tools from Katanga, Democratic Republic of Congo, dated to roughly 90,000 years ago. What he found were barbed bone harpoon points, engineered tools, not improvised sticks. Multi-part weapons designed specifically for spearing large river catfish. And here's what makes it stranger. The complexity of those harpoon tips rivals tools that mainstream archaeology, until recently, thought appeared only 30,000 years ago in Europe. Mainstream anthropology has a solid framework for this. It's called the coastal migration hypothesis, sometimes called the beachcomber route. The theory goes like this: as Homo sapiens expanded out of Africa, coastlines provided a reliable, predictable food corridor. Shellfish are slow. Tidal pools are accessible. You don't need a spear to collect mussels. So early humans followed the coast, learned marine environments, and gradually developed more sophisticated fishing techniques over tens of thousands of years. It makes sense. It's logical. It explains the geographic spread of early human populations along shorelines and river deltas. It's probably a real and important part of the story. But it doesn't explain why the tools were already so advanced, or why we find engineered barbed harpoons in landlocked Central Africa, thousands of kilometers from any coastline, 90,000 years before Europe ever invented them. Go back 100,000 years. Picture the banks of the Congo River Basin, one of the deepest, fastest river systems on the planet. The water is murky and heavy. Giant Nile perch and catfish the size of a man move through it. There are no boats, no nets, no metal. At Katanga, in what is now the Democratic Republic of Congo, archaeologists excavated a river terrace site in the 1980s and 1990s. What they pulled from the sediment were finely carved bone harpoon points, up to 30 centimeters long, with rows of backward-facing barbs cut into the shaft with deliberate precision. These weren't found alone. They were found alongside the bones of enormous Clarius catfish, fish that can grow over a meter long and live primarily in the depths of fast-moving water. You can't catch those by hand. You can't stumble into them. You need a plan, a tool, and the understanding of animal behavior that comes from generations of accumulated knowledge. The bones and tools together suggest something extraordinary: cooperative group fishing. Drive fish toward shallows, cut off escape routes, strike with a harpoon. A strategy, not instinct design. Your instinct to outsmart a problem rather than outrun it is not a modern invention. It is at least 90,000 years old. And your brain still runs that same program every time you figure out a shortcut, every time you use a tool instead of your hands. No species in 4 billion years of life on Earth has moved from improvised tools to engineered multi-component weapons in the span of a single geological blink. Crocodiles have been ambush predators for 200 million years. They are magnificent. And in all that time, they have not changed their technique by a single step. Great white sharks perfected their hunting form roughly 11 million years ago. They have not improved it since, because they don't need to. And then there's us. We went from sharp rocks to barbed bone harpoons, from wading shallows to reading tidal patterns, from individual scavenging to coordinated group drives, from eating what the river gave us to engineering what it would give us next. All of that in under 100,000 years. In evolutionary time, that is basically overnight. And scientists still cannot fully agree on what triggered it. We don't fully know. We've got the bones. We've got the harpoon points. We've got the fish remains, the shell middens, the carbon dates. We have pieces, extraordinary pieces, but we don't have the full picture. Maybe the urge to fish wasn't just about hunger. Maybe standing at the edge of water, reading its currents, learning its rhythms, maybe that was an early form of science, of pattern recognition, of wanting to understand something, not just exploit it. Because if our ancestors were already doing this 100,000 years ago, already engineering tools, already reading animal behavior, already teaching each other how to hunt in groups, then we are far older than the history books suggest. A species that looked at an ocean it could not swim, a river it could not outrun, and a fish it could not catch, and decided to invent a way anyway. And we still don't know exactly when that decision first happened.